Hi students, welcome to Chem Glory. Today's topic is Law of Multiple Proportions. This is third law of chemical combinations. This law is proposed by Dalton in the year 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combines with the fixed mass of the other element are in the ratio of small whole numbers. Students, this seems to be a very big statement, but we can understand easily with the help of examples. Okay, let us take three compounds, three different compounds, AB, AB2, AB3. Here, when we compare A and B, in all the three compounds, A has the same mass. So, we will denote A as fixed mass. Okay, B has different masses. Let it be X, Y, Z. Okay, so here when we take the ratio between X, Y, Z, this should be in the form of small whole numbers. Okay students, now let us understand this statement with some more examples. I have taken first example as hydrogen and oxygen. Here, hydrogen combines with oxygen to form water. In second case, again the hydrogen combines with oxygen to form hydrogen peroxide. Okay students, here what happened? Two elements, they combine to form more than one compound, right? They formed water as well as hydrogen peroxide. Now, let me find masses of each element in this particular compounds. So here I have written two compounds, that is H2O and H2O2. And what are the elements in the two compounds, students? One is hydrogen and another one is oxygen. So now let's find the mass of each element in the particular compounds. Okay, what is the first compound? Water. Here hydrogen, we have two hydrogens, so 2 grams. Here oxygen, we have one oxygen, so finally it is 16 grams. And in the second case H2O2, we have two hydrogens, so hydrogen 2 grams. Next we have two oxygens, so 2 into 16, 32 grams. Okay students, let's find the ratio of different masses of this oxygen, that is M1 and M2. So M1 by M2 is equals to 16 by 32, that is 1 by 2, that is equals to 1:2. Second example, carbon and oxygen. Here carbon combines with oxygen to form carbon monoxide and carbon dioxide. Okay, here see students, two elements combine to form more than one compound. Okay, so here let me draw a table and let us find masses of each element in two different cases. I mean two different compounds. Okay, so what are the compounds we got? Carbon monoxide and carbon dioxide. Okay, so what is the mass of carbon in carbon monoxide? 12 grams, because we have one C, and O, we have one O, so the mass is 16 grams. And in the second case we have one C, so it is 12 grams, but we have two O's, so 2 into 16, 32 grams. Okay students, so now what is the fixed mass? Which element has a fixed mass? Students, carbon. Which element have different masses? Oxygen. Okay, 16 and 32. Let me denote this as M1, M2, and let me denote this as M1. Okay, in this both cases, the smallest number is 16. We have to put the smallest number in the denominator. Okay students, so M1 by M2 is equals to 32 by 16, that is equals to 2. Okay students, so finally we got 2 as a whole number. So this carbon and oxygen combination follows law of multiple proportions. But here I have found this for 12 grams of carbon. Okay, but I wanted to find this for 1 gram of carbon. If they ask you a question like what is the mass of oxygen for 1 gram of carbon, in CO. Then you have to solve the question like this. Okay. In first case, 12 grams of carbon is equals to 16 grams of oxygen. Then what is the mass of oxygen for 1 gram of carbon? Okay. Now let's crisscross it. 16 into 1 by 12. Finally is equals to 1.33 grams in CO. In next case, that is CO2, 12 grams of carbon is equals to 32 grams. Okay. So what is the mass of oxygen in 1 gram of carbon? 1 gram of carbon, we have to crisscross it. 1 gram of carbon is equals to 32 by 12. That is equals to 2.67 grams. Let us denote this as 1.33 grams as M2 and 2.67 grams as M1. Finally, we have to take the ratios of oxygens in two different compounds. Okay, students. So 2.67 by 1.33 grams is equals to 2. Okay. We got 2 as a whole number. From this, we have to understand that carbon and oxygen combination follows law of multiple proportions. Next example. Students, you can see this example in NCERT textbook as 1.21a, that is nitrogen and oxygen combination. Here, nitrogen and oxygen combines to form more than one compounds, that is N2O, NO, NO2, N2O3, N2O5. Okay, students. Here, let us find masses of NNO in each particular compound. Okay. So, what is the mass of N? 1N is equals to 14 grams. What is the mass of O? That is equals to 16 grams. Okay, students. Now, how many N's we have in this N2O? 2 N's. So, 2 into 14, 28 grams. How many O's we have in this compound? 1. That is 16 grams. Okay, students. So, like that, we have to find masses of N and O in each and every compound. We have here 1 N, so 14 grams, 1 O, 16 grams. We have 1 N, so 14 grams. We have 2 O's, so 32 grams. Here we have 2 N's, so 2 into 14, 28 grams. Here we have 3 O's, so 3 into 16, how much, students? 48 grams. Here we have 2 N's, so 2 into 14, 28 grams. And here we have 5 O's, 5 into 16, 80 grams. In this particular example, you can ask me a doubt like, we don't have any fixed mass in this both elements. We have different masses of nitrogen and oxygen. So how to solve this problem? Here, it's our decision to make nitrogen or oxygen a fixed mass. Okay, students. So here I found 28, 28, 28. So now I wanted to make nitrogen as a fixed mass because I have found more same masses. Okay, in nitrogen. Now I wanted to multiply this with 2 so that I have to multiply this with 2 so that N will become 28 grams. And we have to multiply this 2 with O also. And in the third compound NO2, to make it as 28, we have to multiply with 2. And we have to multiply 2 with O2 also. So finally, we'll get masses as 2 into N, 2 into 14, 28. Okay, 2 into O, that is 32 grams. And here 2 into N, so 2 into 14, 28 grams. 2 into O2, right? So we'll get 2 into 32, that is 64 grams. Okay, students. So here you can observe we have N as fixed mass O as different masses. What does the law state, students? The law states the masses of the different masses of the element, that is O, that combines with the fixed mass, these masses should be reduced to the small whole numbers. Okay, so let us find the ratio of this different masses. Okay, 16 is to 32 is to 48 is to 64 is to 80. This, when we simplify it, we'll get as 1 is to 2 is to 3 is to 4 is to 5. Let us solve some problems so that we can understand this law of multiple proportions easily. Okay, students. Here, first question is 128.64 grams of iron oxide decomposed to form 100 grams of iron and 28.64 grams of oxygen. 142.97 grams of a different compound, iron 3 oxide, decomposed to form 100 grams of iron and 42.97 grams of oxygen. What is the whole number ratio of oxygen between the two compounds? Okay, students, don't get tensed after seeing the question. First, try to understand each and every point in the question. Okay, here, what are they saying? We have two compounds, okay, that is iron 2 oxide and iron 3 oxide. So, these two compounds, they decompose to form iron and oxygen. Okay, so now let's write that. Iron 2 oxide, this decomposed to form iron and oxygen. Okay, here this is in the first case. What is in the second case? Iron 3 oxide decomposes to form iron and oxygen, and they have given masses of these two compounds. What is the mass of iron 2 oxide? 128.64 grams. What is the mass of iron? 100 grams. And here 28.64 grams. Okay. And in the second case, mass of iron 3 oxide is 142.97 grams. And mass of iron is 100 grams. And mass of oxygen is 42.97 grams. Here you observe, students, iron has a fixed mass, okay, 100 grams and 100 grams. Oxygen have different masses, okay. So now we have to solve this problem in this manner. Here in the above masses, 28.64 is the smallest number. So let me divide by 28.64. 28.64 by 28.64, that is equals to 1. And now this is in the first case. In second case, 42.97 divided by 28.64. Here it is 1.5. So finally the ratio is 1:1.5. But 1.5 is not a whole number. So now let's multiply it with some number so that it becomes a whole number. Let me multiply this 1.5 into 2. We have to multiply this 1 also with 2. So finally we'll get ratio as 2:3. Second example, the mass of oxygen that combines with 1 gram of sulfur to form 3 different compounds are 1.750 grams, 0.8750 grams, 0.4375 grams respectively. Shown up, this data illustrates law of multiple proportions. This is first question, and this multiple choice is the second question. Okay, first now let us solve the first question. Here, what is a fixed mass, students? Which element is having fixed mass in the above question? 1 gram of sulfur. Okay. And which element is having different masses? Oxygen. Different masses oxygen. Okay. So now, what are the different masses? Let us denote them as A, B, C. Okay. Different masses of oxygen in different compounds. That is 1.750 grams, 0.8750 grams. Third one is 0.4375 grams. Okay. We have to solve this problem as compound A compared to compound B. Okay. What is compound A mass? 1.750 by 0.8750. That is, if you simplify, we'll get 2 by 1. 2:1. And in second case, compound A compared to compound C. That is 1.750 divided by 0.4375. And when we simplify it, we'll get 4:1. And in the third case, compound B compared to compound C, and this is 0.8750 divided by 0.4375, and finally we'll get 2 by 1, 2:1 ratio. See students, in all the three compounds we got whole numbers. Okay, the masses of oxygen in different compounds are reduced to the whole numbers. So now we can tell that this data illustrates law of multiple proportions. And next question, you have to they have given you 4 options. Okay, 4 times of oxygen in compound A compared to compound C, 2 times of oxygen in compound A then compound B. Like that, they'll give you some options and they will ask you which of the option is correct, like A and B are true, like that. Okay, for that you have to just understand this whole number ratio. Here, what does this whole number ratio mean, students? 2 times of oxygen in compound A than compound B. 4 times of oxygen in compound A than compound C. 2 times of oxygen in compound B than compared to compound C. The same sentences are there in the above question. So now here in all the 4 options, here A, B, D are true. Third example, hydrazine, ammonia and hydrogen azide all contain only nitrogen and hydrogen. All these 3 compounds contain only nitrogen and hydrogen. Okay, the mass of hydrogen that combines with 1 gram of nitrogen for each compound is so and so respectively. Show that the above illustrates law of multiple proportions. Here we have to solve in the same way, students. We have here, what is a fixed mass, students? What is a fixed mass given? Fixed mass is 1 gram of nitrogen. What are the different masses? I mean, which element is having different masses? That is hydrogen. So now we will take these 3 masses. I mean, we'll denote this 3 masses as A, B, C of hydrogen in different compounds: 144 grams, 216 grams and 240 grams. Okay, so now let us solve this. Here in this case, C by A. Okay, 240 by 144, that is equals to, we'll get 1.67. But to make it a whole number, this is not a whole number, right? To make it as a whole number, we have to multiply numerator and denominator by 3. So finally we'll get 5 by 3. Okay, what does this mean, students? We need 5 molecules of hydrogen for every 3 molecules of hydrogen in compound A when it is combined with 1 gram of nitrogen. Okay, and in the second case, B by A. Here, what is B? I mean, mass of B, 216 by 144, that is equals to 1.5 by 1. Here also, it's not a whole number, so when we multiply numerator and denominator by 2, finally I'll get 3 by 2. And in the third case, C by B, that is, what is the mass of C, students? 240. 240 and B is 216, and we'll get 1.11. Okay, by 1. This is not a whole number, so let me multiply the numerator and denominator by 100, and I'll get the answer as 111 by 100. So the ratio of hydrogen is 111 by 100th when combined with 1 gram of nitrogen. And in the second case, the ratio of hydrogen is 3 by 2. 3:2 when combined with 1 gram of nitrogen. And in the first case, the ratio of hydrogen is 5 by 3 when combined with 1 gram of nitrogen. So here finally we got whole number ratios. So we can say that this problem illustrates the law of multiple proportions. Okay students, if you like this video, please like, share and subscribe our channel Chem Glory. Thank you students.